All right, welcome back to the Check Your Understanding. I hope that you've tried each of these and we'll see if you got them correct. All right, so the first one is a square root function. So this is number 5, f of x equals the square root of x plus 3. So this is a square root function. It's been shifted to the left 3. So our graph would look something like this. If we invert this graph, it would still be a function, right? Only our point would be down here, and our graph would now be going something like, so we're at 0, negative 3, so we'd be at, so this is negative 3, 0, we'd be at 0, negative 3, and then we're at negative 2, or positive 1, so we'll be at 1, negative 2, and our function would be doing something like this. So there's no reason to put any restriction on this graph since both will be a function, so no restriction. All right, number 6, it's not f of x, it's g of x equals, I'm just going to rewrite this right away as a square root. So again, this is a transformation, it's been shifted up 1. So this square root function will be doing something like this. If I invert it, right, this point that's at 0, 1 will now be at 1, 0, and it'll look something like that. So there's no reason to put a restriction because both will be functions. Let's take a look at number 7, however. All right, number 7 is p of x equals x minus 5 squared. So this function is a quadratic function shifted to the right 5. Now, if I invert this function, right, this point 5, 0 will become 0, 5, and it'll be facing this way, so it will not be a function. So yes, we will need a restriction. Our restriction, so we're going to look at the domain and range. So what we want to pick is we want to pick either this side of the graph, or we could pick this side of the graph. We only want one. So there's two separate restrictions we could pick. We could either pick from x greater than or equal to 5, or we could pick from x less than or equal to 5. If I pick greater than 5, I'll have the right-hand branch. If I pick less than 5, I would have the left-hand branch. And so my range, though, would still be from 0 to upward infinity. So my range would be from y is greater than or equal to 0. So our restriction for the domain on the second graph is, so our domain would be x is greater than or equal to 0, which is true. And then for y, it would be y greater than or equal to 5, or y less than or equal to 5 would be our range. And so the restriction that we would have to put on this graph would be one of these two restrictions on the domain. All right, and then the last one, number 8, this is also a quadratic. So this quadratic is not in standard, or is in standard form. It's not in vertex form. I'm going to give you a refresher on how to put that back into vertex form. So for vertex form, you take the b term, you use this little formula, x equals negative b over 2a. And this gives you the x coordinate of your vertex. So in this case, b is 6, so this would be negative 6 over 2a, which is 1, which would give me negative 3. And I substitute that back into my equation. So negative 3 squared plus 6 times negative 3 plus 9. This would be 9 minus 18 plus 9. This would be negative 9 plus 9, and our vertex would be actually at negative 3 comma 0. So now that I have my h comma k, I could rewrite this as q of x equals a is 1, so x minus h, x plus 3 squared, and then plus k. This is the same function but in vertex form. Okay, so this graph will shift left 3 units. So that tells me that my graph will be over here 3 units to the left. And then for this function to be an inverse function that's still a function, we would either need to take only the left-hand side of the graph, which would be where x is less than or equal to -3, or we would have to take only the right-hand side of the graph, which would be where x is greater than or equal to -3. So that would be our restriction on the domain. Okay, so finally we get into this idea about a function being one-to-one. It says a function is defined as one-to-one if for each number in the range of the function there is exactly one corresponding number in the domain of the function. If f of x is a one-to-one function, then it will pass both the vertical and the horizontal line test. So a horizontal line test is a way, it's similar to the vertical line test, it's a way for us to tell if a function is one-to-one. So on number 9, it's asking us, is g from item 1 a one-to-one function? So let's go back to g on item 1. So on item 1, it says, is this a one-to-one function? So we're going to do a horizontal line test. And because this graph will fail the horizontal line test, it is not a function. I'm sorry, not a function. It's not a one-to-one function. Okay, it says make a conjecture about a function whose inverse relation is a function. So what we've seen so far is that for a function to have an inverse function that is a relation, it has to have only one branch, right? So a function like this will not be the inverse function will not be a function, it'll be a relation unless we restrict the domain. And so my conjecture is that it has to be a one-to-one function, or it will pass the horizontal line test, or i.e. it will be one-to-one. All right, next, check your understanding. It says determine whether each function determine whether each type of function will always, sometimes, or never have an inverse that is a function, assuming the domain of the function has not been restricted. Explain your reasoning. So a linear function, I can see that a linear function will pass both a horizontal and a vertical line test. It'll pass the horizontal line test. It'll only pass in one spot. It'll pass a vertical line test. It'll only cross in one spot. So this will always, well, actually, now, they're always a function as long as they're not a horizontal or vertical line, okay? A quadratic function. So a quadratic function we know would look something like this. It's going to fail the horizontal line test. It will pass the vertical line test. So the original function will be a function, but the inverse function will never be a function unless we restrict the domain. And so this is never. And a square root function will do something like this. And so if we invert this, it'll only, so first it'll pass the vertical line test and the horizontal line test. It'll only cross through in one spot. And so this will always be a the function will always be invertible. All right. So now that was the end of page 124. I hope you